Can you all see my screen?
Yes.
Okay, so thank you very much for the invitation to speak at this workshop. I'm very honored to be asked, and I think it's a wonderful workshop that Professor Mishra and his group. I've been in contact with Matulika Patak, and I hope I didn't butcher that name. Apologies if I did. Have been putting together. Um, I'll be talking a little bit today about eye tracking, language processing, given lifespan variability, bilingual effects, and also something that is called register variation. And I will define that once we get to that part of the talk. Thanks again for having me. Um, Okay, so uh, what sort of research are we doing? I'll start actually right off the bat with a quick illustration of an experimental setup that you might see in our lab. So, for instance, you might see a photograph such as the one here of a relatively sort of, humble house. You might see this photograph and then read a sentence such as, "The farmer of Withering lives in a rickety tin shack." Alternatively, you might see a really posh mansion here, and then read the same sentence. And what we can do is we can eye track participants' attention to the sentence when they read something like "The farmer of Withering," so he's sort of moving along, the reader lives in a rickety tin shack. All right, you see that there's a match between the sort of left photograph of a hut, which would fit with rickety tin shack, and there's a mismatch with the mansion, the palace that you're seeing on the right. So we can use manipulations like this that fit or don't fit with language to see at what point do you integrate the context that you have just seen, say a photograph here, but also other context with the sentence. And you can flip this to counterbalance effects of the image, where you have the same pictures. You either see the humble abode or the mansion, but then you read a different sentence, like "The Count of Withering resides in a splendid manor." And this time the match is for the splendid manor, and the mismatch is for the rather sort of, sort of humble abode on the left side. This is, of course, graded and not a sort of black and white distinction, but you might get effects in the reading times, and we can eye track those. And from these eye tracking results, glean some insight into, well, when do people integrate the non-linguistic or also linguistic context with ensuing language? All right, that just as an illustration, I hope it helps to sort of situate broadly what we are doing. So today I will be starting off by talking a little bit about language representations, since you've just seen the context, right? And the sentences that we use. So it's worth thinking about, how can you represent these if you want to also come up with theoretical, or in some cases computational models of context effects in language processing. And I'll be touching a bit on reference. So by reference, we mean how individual words relate to things, representations of things in the world out there, such as, say, a woman relating to the woman that you see, and the sort of linguistic stimulus, woman, but then also extending that to actions and events, and thinking about grounding via eye movements, via visual attention. And I'll be talking a little bit about one account that we have been using, which is shorthanded here as CIA, the Coordinated Interplay Account. And ways of extending the coordinated interplay account, given variability that you see in language. And you're well positioned there in Hyderabad with Professor Mishra, who's actually been looking at variability for a long time now. I recall findings from sort of around 2012, very interesting, on literacy and language processing that we'll briefly touch on as well. So what if you go beyond reference, beyond just looking at individual objects, beyond our student populations, towards kids and older adults? What if you factor in bilingualism, and the knowledge that comes or doesn't come with it, and then also non-standard language? And this is where register comes into play, right? So if you're reading a standard textbook, that's written in standard language, in German or English, for instance, or in any other language. But then you also get types of language that you might use in a pub, or when chatting with friends, that are more colloquial. And that's what we mean by register, this variability of language to standard and non-standard aspects, as a function of the context that you're in. Are you in an interview, at work, or are you with a friend in a pub, to just give an example? All right. So what about the representations that I mentioned? Well, for referential relations, so between individual words and objects, there has been a bunch of approaches to how we could, capture reference. Some come from sort of the language psychology side, like Lawrence Barcelou, on the left-hand side here, with perceptual symbol systems, where you have forms of words. So cup could be written in small or in large. It could be slanted, but it's still cup, right? And they all map onto the single referent of a cup. Then you could have different percepts where the cup is tilted, and that's not really rendered in language. You wouldn't typically print the word slanted, right? So you might need a sort of different object representation. This would be the representation layer, this would be the referent layer, and this would be the sort of word layer. You might need to sort of more imagistic representations to render that this object is now tilted. So that's ways of representing individual sort of aspects of the world, and of language, where different facets of language all map onto the same referent, but different sort of referents may map onto different representations here. You could also go for not perceptual symbol systems, but something that's called embodied construction grammar, which has been pursued by Ben Bergen and Nancy Chang, where again, you've got the similar approach here, right? You've got word, sort of a word layer on the left-hand side here, then something that's called a schema for cat, linking to the perceptual side here, and then you've got different reference. The cat could be sitting, it could be craning its neck, it could be on its four paws. None of this would be captured by just the word, but you sort of can capture it via a schema for cat. So this is giving you some possibility of representing the perceptual world. In addition to embodied construction grammar and perceptual symbol systems, you could also go for a Jackendorfian approach, where you have different layers for syntax and phonology, and a sort of descriptive conceptual tier where you represent events, such as a fox eating grapes, eating here as the predicate, and then fox and grape as the objects involved. But then the question is, how do you map this to the world? And for that, Jackendorf has a referential tier where you can co-index. You give indices in the conceptual layer and indices in the referential tier, and you can sort of ground language in that way. So these are different possibilities. But what about extending it to events? So Glenberg and Kashak remarked that there's evidence supporting a specific type of interaction between syntax and semantics that leads to understanding. The syntax specifies a general scene, and the affordances of objects, so affordances are things that you can do with objects, like sitting on a chair, are used to specify the scene in detail sufficient to take action. So this is moving from just representations of objects in the world to events in the world, but then also how you interact with objects and how language might interplay with representations of the world in constructing meaning. All right. There are other accounts that have been tackling this problem. So how do you relate language processing in real time to perceive things. And one of these accounts is the indexical hypothesis by Glenberg and Robertson. So in their account, there are no precise claims regarding the integration of words, sentences, and experience-based object-related knowledge. And why am I highlighting this? I'm highlighting this because this is a workshop on eye tracking, and eye tracking is a method that's excellent for getting at the fine temporal resolution. You will have probably already heard some of this in the morning. I saw Professor Mishra gave a talk this morning, and you also had more methodological sessions, I believe. So once we sort of get to thinking about grounding, relating language to the world, and eye tracking, then the question is, well, attention is in play here, so that could be a mechanism for making this relation in real time happening. And that's something that not too many accounts have spelled out, thinking precisely about when the connection is made, right? At what point in time during the sentence, during language processing. So the focus instead has, and for good reasons, been on the nature of representations. Most of you will have heard about the embodied language community and their focus on what representations do we want, right? That's sort of tying in with the perceptual symbol systems representations and the embodied construction grammar approaches that I've just touched upon. So there is also work that has extended that to comprehension processes, a paper by Lawrence Barsalou in discourse processes, for instance. But the focus is then on, do you have representations that are related to what you've seen? So are they modal or are they more abstracted, amodal? Okay. In terms of the effects on real-time language comprehension, a bit more unspecified, right, to map out that timing. And this is something that we have tried to add to the literature with the coordinated interplay account. All right, when we zoom in on real time via attention, I like to touch on a very early study by Cooper in the 70s already. That paradigm then sort of got forgotten for a long time until Mike Tannenhaus and his group famously resuscitated it in the 90s. But this early study is just fantastic, actually. So you see a printed text here, but in this study, the text was played out via speaker. So it was auditory speech presented to participants while they looked at sort of grids like this one here. And what Cooper noticed is that there was a very close relationship between what people heard and how they directed their attention. So at photographic here, they, in the text, while on a photographic safari in Africa, people at photographic started to look at the camera, for instance. Then in Africa, they shifted their attention to the lion. Later on, breathtaking got them to look at a snake that takes away your breath, right? What else? Wild terrain. There's no terrain depicted, but there's a tree that's associated. Then when a dog is named, they look at the picture of the dog. So there's a range of language picture relations here. Some referential. When you hear dog, you look at the dog, but some also more associative, like breathtaking, getting you to look at the snake. Or here, what do I have here? Wormed as a verb also triggers looks to the snakes and so on. This works also for pronouns. I'm not going to go through all of this now. For verbs that sort of restrict your attention to things. For instance, when you're thinking about or talking about taking a photo, then you might start to look at the camera already, right? Because that's the instrument you could use to take a photo. And Cooper at the time realized what he had there. He concluded that in particular, the scanning of those elements which are most closely related to a given word should be initiated during or closely following the pronunciation of that word and without prior instruction to do so. So he compared these kinds of looks to images as people heard sensible text to a more sort of random pairing of pictures and spoken input. And he concluded further, such behavior, if confirmed, could be viewed as an active online anticipative process where the contemporary visual field of an observer is subjected to his continual interpretation in terms of the language heard. And conversely, so it goes both ways, as a process in which ongoing heard language is interpreted word by word in the context of the contemporary visual field. All right, so since then, there's been a myriad of studies and results looking at language processing using this now called visual world paradigm in one way or another. We know that people very rapidly establish reference, so they look at things as they're mentioned. We also know that other linguistic and world knowledge can direct eye movements to things, and we're sort of relying on this rapid link between what people hear and where they direct their attention to examine the time course of language processing. We also know that different scene contexts have a clear effect, and we can use the paradigm to look at forward-looking processes. What do people expect to be mentioned next? Which often is called prediction, but also tapping into working memory and sort of re-inspecting previous object locations. If you haven't heard it yet, that you often find that as blank screen paradigm, where you see a picture, it gets taken away, and then you hear a sentence, and you can look at, do people inspect while they look at a blank screen and hear language? Do they inspect locations where objects have previously been? Okay, so and that works. It again has this close temporal coordination as a hallmark. From that, we could conclude that language processing and the relation between language processing and visual attention to things and taking information from the context is rapid, incremental, and predictive. But how pervasive is this? Mostly the studies that you have here, they look at the student population from 18 to 31 years of age, and not much beyond. What delays do we get, for instance, for children, for older adults, but also for people that may come with different knowledge? And Ramesh Kumar Mishra has done some interesting research together with colleagues here, looking at the effects of literacy, for instance, the reading ability in India, and found that considerable delays can happen as a function of your language training. So it's not always that predictive, that rapid. Similar delays have been observed for the presentation of complex videos or very cluttered scenes, or when there was a cognitive load. And that holds for both monolinguals, L1 users, and L2 users, and that would be sort of research from Eine Ito's endeavors. So there are some limits to this, and it's interesting to look at the borders of this, at the variability, as we are trying to accommodate language processing. You sort of have quite a bit of insight on the bulk, but the sort of margins, the variability, much work remains to be done. All right. So if you're thinking about language processing in context and accommodating it, you've got representations on the language side, as we have seen, and you've got representations on what I call now the scene side, so what you see in the world. Both are informed by linguistic and world knowledge as you process language, and you've got an attention mechanism relating the two. So these are sort of the essential ingredients in accommodating the interplay that happens here. What could that interplay look like? Here is an example. So you might think about it as a sort of sequence of interpretation and attention steps, where you start with sentence interpretation as step I. When a word is heard or read, you integrate that word into the interpretation. You're updating the expectations that you may have, perhaps from previous contexts. You're keeping track of things in working memory. So this is your working memory. The interpretation and stands for expectations, and scene keeps track of the scene representations. Okay, so this is sort of what you see in the world, and the representations that come from it actually here from a previous step, hence -1. You're now at step I. This is from I -1, actually I double prime -1. And the interpretation here keeps track of what you get from the language side. All right. Once you've integrated the word, updated your interpretation and expectations, you get to the next step here. And this could be overlapping, right? Not strictly serial, utterance-mediated attention. So you've got an interpretation, an expectation, so that can guide your attention, your searching, working memory internally, but also looking at things that are around you. You might merge new scene information as you see it, and if scene information is no longer present, the representations of it may decay. All right, you're again keeping track of things. Your representations in working memory is the assumption here. And then once you've sort of had this utterance-mediated attention step or slightly overlapping with it, you're bringing together what you have from language in terms of representations and what you have from the scene in the scene or context integration step. So the same would work with a linguistic context. You're reconciling the interpretation with the scene representations. And the assumption here is that we can model this via a co-indexing mechanism that's borrowed from the Jackendorf framework. You might also revise the interpretation if you've seen things in the world, in the scene, that give you good reason to think there should be a change in the interpretation, and you can sort of reconcile the expectations and with the scene representations. So this is sort of in a nutshell one way how you could model the interplay between language processing and what you get from the non-linguistic or also a linguistic context. And you're keeping, again, track of representations in working memory. You're now here at step I double prime, and once the next word comes in, you'd go back to the sentence interpretation step, and you'd then be at step I +1 and move through the circle again. All right. So equipped with this and with the knowledge that we've just sort of discussed regarding eye tracking, we can look at individual examples. For instance, a first set of research looking beyond reference and beyond just young adults. So this is research by Katja Marquardt, actually her PhD research, where she was interested in how 4 to 5-year-olds, students and older adults process language in relation to the context. So she's looked at different age groups and also different kinds of relations between language and the non-linguistic environment. So the comparison here is between a verb and an action that the verb refers to in an event depiction. How quickly does that influence language processing compared to what one might see as perhaps more indirect relations and perhaps relations that are strained a bit more by working memory? When you see somebody smile, preceding a sort of target sentence, a sentence that is then eye-tracked in its processing. So you see a smile and then have a sentence containing, say, a valenced verb adverb sequence, like, tickling happily, that might be characterized as a more indirect relation than a verb relating to an action. So the question is, would you get similar effects for these different kinds of relations, both thinking about the age groups, perhaps some cognitive decline happening here, and working memory, cognitive resources coming into play as a function of the earlier age groups in particular as well. And then variability as a function of different language world relations. All right. So based on the coordinated interplay account, the prediction would be that direct referential relations are very rapidly used in language processing. As a word comes in, it directs your attention, it gets integrated in the interpretation and directs your attention, and there's a priority in that account for establishing reference over other things. But overall, the account would predict that, yep, there is relatively rapid effects of context information. Okay, in this study, the trial structure was like you see depicted here. You had a speaker video with the exclamation "look" to get also the younger participants' attention, so dynamically presented, then that would disappear. And then a target scene comes up on the screen where you see a sort of little bug, a tomcat, and a rat or a mouse here. The labeling of the images was normed, and then you get a sentence like, the ladybug tickles happily the cat. Now, this was presented in German, and there's a bit of a tweak here in that these were all object first sentences, right? So I said the ladybug tickles the cat, but it's actually the ladybug being the object, right? So a passive would sort of be a rendering, right? The ladybug is being tickled by the cat. That's just not quite the construction in German. It's a sort of object, verb, subject ordering that you have there. And these are difficult sentences for kids in German. They're difficult without context. They're not the standard. They're non-canonical, so to speak. And so we can sort of ask, well, when they have this unusual sentence beginning, they do have the case marking that tells you it's an object first sentence. But you see there's two events happening. One is sort of a tickling event, the cat is doing that to the bug, and the other is like, it's actually, I'm not sure you can recognize that. The pictures would have been bigger in the experiment. These are shackles, so here the rat is kind of doing something not so nice to the ladybug, taking her hostage or something like that, right? If you sort of approximate. And so the question is, once they get to the verb tickles and happily, would that get them to, well, get to the right event via the verb action relation, anticipate the cat before it's been mentioned? And given that they've seen a happy speaker image here, once they sort of hear a sort of, you know, slightly positively valenced verb like tickling and happily, following it, would that also get them to sort of anticipate a character that's actually smiling here, right? The other one is looking neutral to grumpy. All right, the critical regions are the verb and the adverb. And then our manipulations are, of course, the prime phase. Can that facilitate anticipating the tomcat here before it's mentioned, and the action depictions, and we have the age group comparison where we might see some delays as a function of younger and older age. All right, what did we find here? You see the results here displayed in several graphs. You've got the mean log ratio of looks, so that's a ratio of looking to the tomcat versus the other agent character here as a function of action depiction. When the action is depicted versus not depicted, you look more at the tomcat than at the rat, comparatively speaking. So the correct action guides your attention to the tomcat. And this is for younger adults at the verb. All right. What about children at the verb? Again, looking at the action manipulation, right? The tomcat tickling the bug. For children as well, you get a little bit of a boost here with the depicted action. When it's depicted versus when there's no action, you get a benefit. What about the older adults and the action depiction? Same thing. You get a benefit of anticipating the correct agent via visual attention measures when the action is depicted versus when no action is depicted. So that's as far as the verb action referential relations. Quick, rapid effects at the verb for children and younger adults, in a more extended region for the older adults. But what about the emotional facial prime, where we're sort of relying on the connection of the speaker's smile to tickling happily as a happy event? For that, oops, sorry, wrong direction. For that, so for the prime phase, when that was positive and the comparison condition would be negative, you get a boost of looking at the tickling tomcat early only for the younger adults, not for the children, not for the older adults, and it's a relatively small effect here during the verb adverb region. So clear differences as a function of world language relations in how you use those. We may in parts argue that we sort of penalize the emotional facial prime because it's preceding the visual world trial with so the clipart depiction and the language, right, that may play a role here as well. So how can we accommodate these kinds of findings in the, say, the age group variability, right? Likely related to differences in working memory and cognitive resources. That wasn't so much in the original account. So working memory variability was only considered later and has led us to extend the account towards what we now call a social coordinated interplay account, where we're also trying to capture, biological comprehender characteristics like age and associated variables that then impact on cognition and behavior. But also comprehend as experiences as they go through life. For instance, a certain education level, their literacy, their mood, stereotypes about groups of people that your participants may form, or beliefs and world knowledge. So we somehow need to capture these also in modeling language processing and the associated variability that comes with variability in who you are, what your background is, so your characteristics. To do that, and this is again research that Katja Marquardt, here still Münster, before marrying, has done in her PhD research and afterwards. So she introduced PROCOM as a variable, as properties of the comprehender that could be biological or experiential characteristics, and that help you model variability of the comprehender. What she also introduced in that account more explicitly is a gradedness of expectations, so that you can sort of tweak those as a function of comprehender characteristics in a graded fashion. All right, so from 0 to 1, these probabilities are attached now with the expectation that was sort of implicitly there, but not really spelled out, and it's important to spell it out. And they capture the graded nature of the expectations in language processing that we see in many facets of eye tracking paradigms, right? So in sort of thinking about extending the coordinated interplay account, we've now talked about going beyond reference toward action events and other participant age groups. Let's next shift to bilingualism as an example. And here, this is very nice research that Aine Ito and Huang Sisu Nguyen have been doing, where they looked at German-dominant Vietnamese heritage speakers compared to Vietnamese-dominant speakers and how they process Vietnamese. So the question is, what affects the sort of German language knowledge versus Vietnamese language knowledge have on expectations and comprehension of spoken Vietnamese? If you're thinking about the social coordinated interplay account, we've got a model of language user characteristics. So to the extent that language knowledge is available, it should be rapidly used and affect eye tracking measures that we can glean from language processing as a function of the language user's background. The design that we went for here is, includes the visual world paradigm here, spoken sentence presentation. People looked at images, and you'll see an example in a little while, and a 2x2 design. So verb constraints different or similar in Vietnamese versus German, and classifier constraints. These are absent in German. So German doesn't have the same classifiers that can give you information about semantic meaning as does Vietnamese. So that's a real sort of language difference. The verb constraints, they exist in both languages, but then again, they may be similar between the two languages, or they may be different. And verb constraints can tell you something about what comes next, right? What argument in the sentence is okay. And so we have an interesting contrast here between these two languages. Let's look at a slide. This is very busy here, and I'll take you through it. We've got the two factors that I just mentioned here, the verb factor with the levels different mapping and similar mapping between the two languages, and then classifier condition as well, classifier as a second factor here, actually. The kinds of images that people looked at are shown at the bottom here, and the sentences that they heard were something like my, where's a, and then there's a classifier, shirt. Okay. The time windows that we are interested in, the verb window, the classifier window in particularly, and then to some extent also the object noun. Now, what you see printed here in bold, when you see the words in bold, that means at this point in time, disambiguation was possible. So the logic is as before. It's about how quickly can you anticipate a target, which would be shirt or shirts here in the image. So you've got a shirt here, here, and shirts here and here. You've got distractors as well that don't have much to do with the content of the sentence, that are not fitting with the verb. But then you've also got a competitor. For instance, for wearing, you could wear a shirt or you could wear earrings. Now, in German, you'd use the same verb for this. You just say wear, much like in English, right? In Vietnamese, however, mak here works for the shirt, but it excludes the earrings, right? It doesn't work for the earrings that well. So it's a cue to language processing here. So you can disambiguate at this word already and zoom in on the shirt if you've got, you know, very good knowledge here of Vietnamese. Right, for dry, by comparison, so this is the different mapping, right, where German has, you know, different verb constraints. The similar mapping, drying, that could sort of work in both languages. So the verb doesn't disambiguate. That only happens later once you get to the classifier, in this case here, which tells you it's the shirt, the shirts. So you've got the cap classifier here. The competitor, the dresses, would require a different classifier. Okay. But in the third line here, the classifier doesn't help you. So both shirts and dresses would work with this one here. And only once you get to shirts, the disambiguation would happen. All right, and why does the classifier work here? So in the fourth line, but not in the third line, it's because the number changes, right? So you've got dress versus dresses here, right? So it's the same lexical element, but a different number. So the plural takes cap, the singular takes jack, and you've got a singular presented here when the classifier is not shared, and a sort of plural object presented here. All right. So different disambiguation points. And then we also have a pre-registered group comparison here between L1 Vietnamese, L2 German language users, and heritage speakers of Vietnamese in Germany. There was a pretest that made sure these groups really differ in their language exposure. So the heritage speakers have much less knowledge of Vietnamese, different time at which they sort of access that sort of knowledge. For instance, the heritage speakers, the age of acquisition for German for the L1 Vietnamese, L2 German group would be 19 years of age. So they have, you know, by comparison, a much higher self-rated proficiency in Vietnamese than the heritage speakers. And the heritage speaker group would learn German much earlier at age 2, not at age 20. Both groups are comparable in their age of acquisition for Vietnamese, but they differ in the self-rated proficiency. And so the question is, will we get sort of would we see in both groups anticipation as a function of the language knowledge and the different disambiguation points? And then would you get an interaction with the language background, interaction with participant group? So you've got a different mapping where you might see interference from German, and a similar mapping where you expect no interference from German expected. Let's have a look at the results here. These are the, again, log ratios, competitor versus distractor at the verb region and target versus competitor in the classifier region. What you can see here is a clear effect of the verb mapping. So what that means is when the verb was similar, there was more anticipation of the target than it was when it was different. Participants used the verb constraints for anticipation. Oh, and sorry, that was more looks to the competitor than to the distractor, not the target here for the verb, suggesting that they use the verb constraints for anticipation. Because when it's similar, they're sort of compatible with competitor and the target. All right, so for the classifier region, the target versus competitor ratio in focus here. Now we're looking at the target. Here we see a 2-by-2 interaction and main effects. So all of these were significant. The effect of classifier was significant for the similar, but not the different mapping verbs. What that means is, interpretation-wise, that participants were able to use the classifier constraints to anticipate the target when the verb did not disambiguate between the target and the competitor. All right. So both groups used verbs and classifiers for anticipation, but we also saw, and I'm just summarizing this here, clear between group differences. In that the L1 Vietnamese, L2 German speakers were more likely than the heritage speakers to look at the target, so they got a bit of a benefit in all of the time windows. And one interpretation possibility is that they were just more efficient at disambiguating the target from the competitor. And then an effect suggesting perhaps more easy distraction in that the heritage speakers were more likely to look at the competitor compared with the distractor than the L1 Vietnamese speakers late during the sentence, so as they heard the object noun. So relatively rapid effects, but then some differences as a function of your language background that we may want to model with the SCA or other options that are there in the literature. All right, that gets me now to the third puzzle of the talk. We've looked at age differences and the effects of different world language relations in eye tracking studies. We've looked at bilingual background and how that can affect the time course of language processing. And now we're going to look at a further gap in language processing accounts concerning register, so non-standard language. It could be register tied to a situation, so situation adequate language use, where you're assuming that specific facets of the language perform communicative functions that are required by the situational context. A simpler way of saying it is, with an example, if you're in a pub, you might use different language than if you're talking to a professor or if you're in an interview with an industry CEO. Okay. So this sort of variability that we might see as a function of what language do we model and what representations can we use to capture this is a challenge for language processing accounts, and one that we are very happy to embrace in modeling language processing. So we can ask, in this case, what's missing? A bit of a gap in knowledge representations. We need representations that capture social aspects like formality in the accounts, as an example. The basic mechanisms and representations that I've introduced with the social coordinated interplay account would otherwise remain relatively unchanged. You've still got representations on the language side, representations on the scene side, you have linguistic and world knowledge coming into play, and an attention mechanism relating the two. So we sort of need to bring in the representations regarding register into the account. And I'll give you an example of the sorts of contexts that we've looked at in our research here. You see the German original up top and a paraphrase at the bottom. So the investigators discussed the most recent success of the department. The superintendent proclaimed in the meeting. So this is a relatively formal context. Proclaim is a relatively formal verb. Superintendent, investigators, everything about this context, especially also in the German original, which was pre-tested for formality, is formal. Now, if you wanted to model something like this and its effect on a target sentence, how could we bring that into the coordinated interplay account? So our target sentence could start off with the detective duped. So try to get one up on somebody, right? And since we're looking at word-by-word processing as revealed in eye tracking, we are sort of curious to what happens when it becomes clear that there's a formal verb here that should really just work very well with the formal context you have seen. You've read in this context. So we are moving towards a slightly different paradigm here. We are no longer doing visual world, eye tracking, spoken language processing, and monitoring participants' eye gaze to objects in the scene. In this set of studies now, we've looked at eye tracking during reading. So participants read the context and then also read a target sentence, and we are curious to see how do they integrate the two. So in the account now, when you've got scene or context here, it is representations from a linguistic context. All right, we've got the same steps: sentence interpretation, the detective duped, then utterance-mediated attention, now internally in working memory, and also as they read the sentence toward then the sentence. And then you've got the so-called scene integration, so context integration effectively. And we can fill the working memory here, right? So this is a bit more busy than what you've seen before. You've now got PROCOM, including knowledge regarding grammar and register, so situation adequate language use. You've got a few other bits and bobs that have been included over time, a response index, so that if you have to verify a sentence with regards to a context, you can model that as well. I skipped over that extension, but you now see in the interpretation, you've got the detective already rendered as a noun and assigned the grammatical function of a subject. And you've got the verb here, duped. Now, how can you track register and formality? We're doing this here via indices, where you've got R sub P, would track the register formality. P can range from very formal to very informal. And you can see it's set to the extreme here as 1, very formal. You've got this both in the interpretation and also in the preceding context as a setup. All right. So now PROCOM tracks the language user's knowledge. You then get to the next step, utterance-mediated attention. You're just sort of tracking everything here. You're shifting attention. You've got the verb that gets attention, of course, but then also your context in working memory likely gets some attention. We're stipulating here, right? So this is our assumption. And of course, attention in the context might vary as a function of who it is that's reading that context, right? Not everybody would share perhaps the same knowledge regarding formality, or different situations may be viewed as formal or not. So there may come some variability from that, which isn't the focus here, just to mention it also. Right, and then you would sort of access knowledge about register, what's appropriate in a situation, what sort of language. You then get to the scene integration step, I double prime, where you're bringing together the interpretation and the context, and you sort of have a match here effectively. Co-indexing stays as a mechanism and succeeds in this case. So what does that mean for eye tracking and reading times? Well, it means relatively quick reading times. You've got a match here that relates then to relatively quick reading times. All right. What about a change in the context? What if the context is informal and you've got paraphrased here, the girls gushed over the hottest snoop in the series, the girl whispered to the others. So this is still setting up a context for a sentence like the detective duped that we saw before, but it's a very different context, right? And it's been rated as much less formal in a pretest. So you've got girls, yeah.
I'm so sorry to interrupt you, but another 10 more minutes, please.
Yes, thank you. I've just looked at my watch. Yeah, I'm almost done. Okay, so the girls gushed over the hottest snoop in the series. The girls whispered to the others. Gushing, snoop are informal words, so you're setting up a different context, and you're getting the same formal verb. Now you've got an effective a mismatch here. You've got the same steps that we've seen before. But what's different now is that you've got a context that has a register formality rating set to 0. You're taking the extreme here. That's just for illustration purposes. And you still have the formal verb. So you can anticipate, well, attention is going to shift similarly, but then the mismatch resolution is going to be different. Now you've got a sort of mismatching effect at the scene integration step. Co-indexing fails, and in terms of mapping that to reading times should be comparatively more slower in this case. All right, which then allows us to model the eye tracking results that we get, where you see here longer reading times when the context mismatches informality with the verb in the sentence. The interesting part, though, is that these delays as a function of register context formality mismatches, they don't happen quickly. It's not in first pass times. It's total reading time, and it's at the post-critical region, so not at the verb itself, but delayed by one region. The detective duped whoever he duped, that's when you see this effect. So a somewhat slower integration here compared to what you might see for grammar effects, for instance, which we also examined in this study. So we're getting into a more nuanced modeling of language knowledge, of different aspects of the situation, with sort of broadening out our investigation of what in context relates how to what in language. All right, to wrap up, what we've done here is looked at a brief sort of dive back into history, referential relations in language processing, and how you could model these. Really only the tip of the iceberg for context effects. Much variability likely remains to be examined to get a more inclusive picture. Many participant characteristics, which ones do matter and to what extent do they matter. We've seen some evidence that there's lifespan variability, sort of limiting the effects of rapid context in all cases. Adding to that, effects of language education, cognitive load, and language knowledge. High cognitive load, lack of literacy, as in Professor Mishra's work, and less in-depth knowledge can elicit delays. But then the nature of context-language relation matters too. We saw rapid effects for referential links, which the account predicts. But then, relatively speaking, delayed for non-referential contexts like emotional primes and situation formality in reading, which again you could see as non-referential, more hampered by having to maintain a context in working memory. So these are actually then parts of the account that need to be emphasized, right, as causing delays, and we need to sort of explicitly capture this. Last but not least, a take-home message in terms of the methods. Eye tracking, of course, is great to tap into the time course of language processing, but then I also think it's important to accompany that experimental work with active theoretical or computational or both modeling of the context effects via sufficiently explicit processing accounts and representations. And some thank you to funders on the last slide, and of course also to the organizers for putting together such a terrific workshop. Thanks very much for your attention. I'm going to stop sharing here, and I believe you have a little bit of time for questions if there are any.
Hey, how are you doing?
Good. How are you?
So it was a good, comprehensive lecture, and today we had few lectures, and it's the last one. So any questions? Please go ahead. Yeah. Want to ask any questions?
I think I have a question.
Yeah.
Ma'am, all of the studies were based on reading data, as in like, okay, based on data that was auditory input mostly, right? So how do you think this will translate to comprehension study? Like when people are actually speaking, like we saw that they were listening to audio inputs. Do you think we would say similar patterns when they were producing speech across like eye tracking if we were to use the same model that we were talking about in the entire presentation?
Mm-hmm. Yeah, when you're going to language production, right, you sort of need to factor in the preparation time. Thanks for that question. You need to factor in the preparation time, right? You could imagine a situation where you're sort of looking at the context that we've seen here, right? You're forming a concept and a representation of the situation. And from that, then focus on parts of the situation that you want to talk about. If you're thinking about the last example on register and situation formality, I think yes, we would see effects here on the production side, right? People typically tend to sort of tune in with the situation. There's a lot of research, actually more on the production side as well, that has looked at this in more real life situations. So Howard Giles, for instance, Giles and Coupland in the 70s have looked at this in sort of interview situations, how aspects of the sort of phonetic realization would change as a function of the situation you're in, a formal situation, for instance, or if you are in a sort of differential power relation with an interviewer, that would also affect production. Now, if you're imagining you as a producer, you sort of know you're in a formal situation, you probably adjust your repertoire to that. How quickly it happens, would that happen immediately or over several trials? And would you get production comprehension asymmetries? I think is an interesting question, right? Now, for the, let's say, the emotional priming situation, I'd be curious, right? If you sort of imagine the same situation, not on the comprehension side, but you've got an interlocutor that's sort of happy looking and you're supposed to produce something, you might well adjust your repertoire to also saying something a bit more positive, right? The question for us and looking at eye tracking, right, especially in the context at that workshop, would then be, how quickly do these things happen, right? In production, you've got many more challenges. You're not just sort of getting input and gleaning from it, a representation and meaning. You have to do many active planning tasks and accessing of vocabulary. So it's a much more active task. I could imagine that cognitive load could play a bigger role in that scenario, even than in a more passive sort of listening task. But yeah, I think you probably want to start with something like the sort of well-established labeled model, to think through the individual steps with these concrete paradigms and experimental situations in mind, and add to that a relatively sort of, well, close temporal coordination loop that you would assume, right? That would be one way to go. Another way to go in the modeling area would be to say you're taking the coordinated interplay account, and then you've got two loops, right? You've got one sort of modeling on the comprehension side, one modeling on the production side, and you're sort of interlinking both of these. You could draw an alignment as a mechanism, for instance, to get the link going as well. So Martin Pickering and Simon Garrett have been thinking about this for a long time now, and you could try and capture that with something like the coordinated interplay account. So there's various ways you could go to actually realize that, and probably the solution isn't to, when you start out on that, isn't to go for any one of these, but to sort of try out different models and see how well they would map with the production data. Then there's quite a bit of research out on that line, also from Antje Meyer's group in Nijmegen, right? Eva Belke has done a lot of production research, Zenzi Griffin earlier, around the 2000s. So you'd sort of need to dive into that and try and model it.
Thank you
Hope
so
that
much, ma'am.
answers your question.
Yeah, absolutely. Anybody else?
I think we're running out of time.
All right, then. If anybody else has any questions later, perhaps they could email you with their questions, if that would be okay with you.
Absolutely.
And with that, yeah, and with that, we would like to conclude the talk then for today. Thank you so much, ma'am, for giving us time, even though you are on a holiday right now.
Okay.
But
It's been a pleasure.
yeah, it was a pleasure listening to you, and I'm sure our audience was greatly.
Thank you for having me. I wish you a good continuation tomorrow. And if anybody has questions, feel free to send an email. Bye for now.
Thank you so much, ma'am.
Thank you. Bye-bye.